All right, tonight we're going to tackle one free response example together. So before we get started, make sure you grab your calculator. It's handy and you're checking as we go. So let's take a moment and get this copied exactly into our notes. Water is pumped into an underground tank at a constant rate of 5 gallons per minute. Water leaks out of the tank at a rate of radical 2x plus 10 gallons per minute for t is between 0 and 60 minutes. At time t equals 0, the tank contains 50 gallons of water. All right, so let's go ahead and just kind of sketch out a picture of what's happening here. So you have this underground tank, okay, full of water. Put some water in here. And basically, we know when we start, so here's my water, I already have 50 gallons of water. Okay, so that was my initial condition. When this starts, I have 50 gallons of water. And here it says water is pumped into this tank at a rate of 5 gallons per minute. So you've got water coming in at 5 gallons per minute. And at the same time, it says water leaks out of the tank. So now kind of picture maybe there's a hole in the tank and the water's leaking out. Got water coming out of the tank at a rate of radical 2x plus 10 gallons per minute. So you can kind of picture it. Kind of picture like a bathtub that has water in it, and you're letting water drain out as you're letting water come in. So there's two things going on here. So the first thing I like to do on these problems is A, you can sketch a picture for yourself, and B, we're going to list this out exactly what's happening. So I want to make a note. I have water coming into, so let's highlight it as into, and that is 5 gallons per minute. And then I have water that's leaking out, and that's radical 2x plus 10 gallons per minute. And then we have this lovely initial condition which we can't miss. We have 50 gallons when we begin this problem. Okay, now take a note of the units. This is gallons per minute, and gallons. Remember, the units are usually a dead giveaway of what to do. So question A says, how many gallons of water leak out of the tank from t equals 0 to t equals 2? So notice, I don't need all of this information because this clearly says how many gallons leak out. So the only one I'm paying attention to is this function here. Now, what do you want your units to be? Question says how many gallons. Highlight that for yourself. If you just want gallons of this out equation, and it's currently in gallons per minute, you want to lose the per minute, so you're going backwards. So hopefully that's a dead giveaway that you just want to integrate from 0 to 2. Radical 2x plus 10. Okay, make sure you slap a dx on there to identify the variable that we're integrating. And again, we're just going to throw that in our calculator. I think it's 6.920, and you can verify that on your own. Gallons. All right, easy enough for part A. All right, we're ready to tackle part B. Write an expression for A of t, the total number of gallons of water in the tank at time t equals 0. So again, even if all that wording freaked you out, the units should be the dead giveaway. Okay, we want an equation that only talks about gallons. Underline that in your notebook there. We only care about gallons. Okay, and they said call it A of t. So I'm going to start with A of t. And again, anything I write here, I have to get gallons. So picture this tub. It already has 50 gallons in it. So I know I'm going to start with 50. Just to be clear, I'm going to put the word gallons underneath because this equation, like I said, can only have gallons. So we have our tub that already has 50 gallons of water. We have water that's going into the tub, so that would be a positive amount. And my into is 5 gallons per minute. Now I can't just put 5 there because that's gallons per minute, and I only want gallons. So I'm going to have to integrate 5 dx. If that's gallons per minute and I integrate, I now get gallons. Okay, now let's talk bounds. Starting at 0, it says, and it's to any time t. Make a note to yourself that this variable needs to be the same as the bound. Okay, this is a function in terms of t. Now, at the same time water was coming in, we had some water that was leaking out. If it's leaking out, I'm going to subtract an amount. Now the out section here is also in gallons per minute, and my equation can only be in gallons. So I'm also going to have to integrate radical 2x plus 10 dx. And let's talk bounds again. That would be from 0 to, again, anytime t. I can't stress enough that the upper bound and the variable in the problem need to be two different variables. So notice I'm integrating with respect to x, but my function is in terms of t here. So, does this make sense? A of t can only be about gallons. I'm starting with 50 gallons. 5 was gallons per hour, so I have to integrate it to get gallons. This was radical 2x plus 10 was measured in gallons per minute, so I have to integrate it to only get gallons. I'm sorry, this should have been gallons per minute as well. My upper bound will be at any time t that I want to substitute in. So for example, if I wanted to know the number of gallons at t equals 1 minute, I could easily plug a 1 in. If I wanted to know it at 5 minutes, I could easily plug a 5 in. So now part C specifically says, how many gallons of water in the tank at t equals 2 minutes? Well, it's simple now. All I have to do, since this represents gallons of water, is find A of 2. So that's going to be 50 plus the integral from 0 to 2 of 5 dx minus the integral from 0 to 2 of radical 2x plus 10 dx. So once I had written this generic equation, evaluating this is pretty straightforward. And again, we can just plug and chug in our calculator. You're typing it in on your end. I think I get 53.080. And notice again, that's in gallons. All right, ready to tackle part D. At what time t for 0 is less than t is less than or equal to 60 is the amount of water in the tank a maximum? All right, there's a lot going on. You just have to pull out from the beginning of this question. The first thing I want you to highlight is this interval. We talked about this earlier in the week. This is a closed interval. How do we know that? Well, there's that equal to sign there. Anytime you have a closed interval, we apply the closed interval test, also known as the absolute extrema. Okay, so it's either an absolute, max, or min extrema, meaning one of them. But you do have to treat this like an absolute. They're not going to come out and say the words absolute every single time when you have the closed interval. The second big thing you wanted to pull out is the word max. Picture a maximum. Every max or min in the world has a slope of 0. Okay, so you need to set your derivative equal to 0 to get these critical points. So again, we need absolute, which means you need critical points and endpoints. And to find critical points, you set your derivative equal to 0. Now the question is who? Whose derivative are you setting equal to 0? Well, it says the amount of water in the tank. Excuse me. Now we previously just wrote an equation for the amount of water in the tank, and to sum it up, we called it A of t, the amount of water in the tank. So let's recall that function was 50, because it had to represent gallons, plus the amount came in. We had to integrate 5 dx from 0 to t. And we had to take out the integral from 0 to t radical, I believe it was 2x plus 10 dx. Okay, so this is who I'm trying to find the max of. So, again, max means you have a slope or a derivative of 0, so I need to set this guy's derivative equal to 0. So I need to find a prime of t and set that equal to 0. Now it's just as easy as it sounds. Take the derivative of this function. Okay, so the derivative of a of t is called a prime of t. The derivative of 50 is a constant, so its derivative is 0. When I go to take the derivative of an integral, this is called the second fundamental theorem. You do two things. You take this upper bound and you substitute it into every letter x. Well, hold up, wait a minute, there's no letter x. So guess what? There's just no place to put it. There's no place to put the t. You still get the number 5, there's just no place to plug in the t. So that's 5 times the derivative of the upper bound, which is 1. Okay, so the second fundamental does two things. You plug this into every letter x, and you derive the upper bound. Then I have minus second fundamental theorem again. Plug the upper bound in. So the square root of 2t plus 10 times the derivative of the upper bound. Again, the upper bound is t, so its derivative is 1. And you're setting that equal to 0. Now we'll just simply solve this equation. I'm just going to bring that to that side. So 5 equals the square root of 2t plus 10. To undo a square root, you do its inverse, which would be squaring it. So 25 equals 2t plus 10. Subtract my 10. 15 is equal to 2t, so t equals 7.5. Now again, we're only halfway home here. We said it had to be an absolute max, so we have to treat it that way. Okay, I need to use critical points and endpoints. My endpoints are 0 and 60, and I only got one critical point, which is fairly nice. That was 7.5. Those are my t values. Now the second column here is always the who. Who are you asked to find? You were asked to find the absolute maximum of the amount of water in the tank. And again, that was A of t. So I'm going to plug in 0. So I'll find A of 0. So that's going to be 50 plus the integral from 0 to 0 of 5 dx minus the integral from 0 to 0 of the square root of 2x plus 10 dx. This one you can do in your head. Anybody's bounds are the same. That's a 0. So I get a total of 50 gallons. If I want A of 7.5, so again that's 50 plus the integral from 0 to 7.5 of 5 dx minus 0 to 7.5 of the 2x plus 10 dx. Use your calculator, figure out the number of gallons. Obviously the last idea works the same way. I want A of 60. So I start with 50 gallons plus, obviously integrate. And integrate there as well. I would be typing that whole thing in on one line to get the total number of gallons. Then just make sure you answer the question. It says, at what time t is the amount of water in the tank a max? Well, you're going to compare your 3 answers, figure out when you have the maximum amount of gallons, and then respond with the corresponding time t. So I'll let you finish that amount up, but otherwise we'll look forward to some great practice tomorrow. Have a wonderful night.